Hello students, I welcome you all on my YouTube channel. From today onward, we are going to start a new lecture series on differential calculus, right? So firstly, we are going to see what sort of things we are going to cover in it, right? As you can see on the screen, syllabus for the differential calculus has been divided into the 4 units, right? In unit 1, we will be covering limit and continuity, epsilon delta definition of it, and types of discontinuities and differentiability, etc., right? Basically in this section we will be dealing with limit, continuity and differentiability, right? So, and in unit 2 we will be studying mean value theorems, right? And indeterminates indeterminate form, right? And Rolle's mean value theorem, okay, Lagrange mean value theorem, Cauchy mean value theorem, okay. All these sort of things will be done in the unit 2, okay. And unit 3 we will be tracing curves, okay. Yeah, curve tracing will be the main topic of this unit, right? So other topics will be concavity, right? Concavity, convexity, point of inflections, curvature, radius of convergence, and center of radius of curvature and center of curvature, right? Asymptotes, singular points, double points, polar coordinates, relation between Cartesian and polar coordinates, right? And then in last unit we will be dealing with the functions of several variables, right? Okay, limit and continuity of these function, differentiation of these function, okay, right? And Euler theorems on homogeneous function, maxima, minima, and Jacobians, right? So these sort of topics will be done in this lecture series, right? So recommended books you can see on the screen, okay. Yeah, Calculus by Thomas and Finney and Calculus by H. Hinton, right? So these are the recommended books, and this is the syllabus we are going to cover in this lecture series, right? So now we are going to start with limits of a function, okay. Limit of a function, right? So we are pretty familiar with the limit of a function. We have done it in the elementary classes, right? But in this section, in this lecture series, we are not going to go to the basics, but we are just going one step above. That is, we will be discussing in this video epsilon delta definition of limit, okay. Epsilon delta definition of limit, okay. In order to understand this definition, epsilon delta definition, you should know what is neighborhood of a point, right? Because neighborhood will be playing key in this definition, right? So let us understand what is neighborhood first, right? Neighborhood of a point, neighborhood of a point, okay, of a point, right? So let us see, let us take a point, okay. Assume that this is your real line, okay, number line, and this is point C, right? Then if I draw, one second, this is a point C, right? We drew a real line, and this is a point C. Now you see, let us take an interval around this C, right? So this interval, let us call this A and let us call this B, okay. So this interval A and B is containing all the points, okay, which are neighborhood to this point C. So we will be calling this interval neighborhood of C, okay, because number numbers lying in this interval are kind of numbers which are close to C. So we can say these numbers are forming neighborhood of point C, right? So therefore we will be calling this interval AB neighborhood of C, right? So also we are going to be very precise about the neighborhood. So what we are going to do, see, now if I don't want to keep this A and B and here, and I just want to talk about in terms of distances. Okay, so if this point is C and distance from here to here is delta, and here to here is also delta. Okay, so this point could be called C minus delta, and this point could be called C plus delta, right? These are the 2 points. And if now I consider this interval C minus delta to C plus delta, this is again neighborhood of C, right? This is again neighborhood of C, right? So this is where the distance of the farthest point is delta, right? So that's why this neighborhood is known as delta neighborhood, right? Because distance or length of the neighborhood is delta, right? So this neighborhood is known as delta neighborhood. So nextly it can be also written in the set builder form. Okay, neighborhood in set builder form can be written as all the points x is x, okay, such that x belongs to interval C minus delta, C plus delta. Okay, so AB is also the neighborhood of C, and this is C minus delta to C plus delta is also the neighborhood of C. Just we have changed the notation, we have just changed the name of the extreme point, end points का name change किया है बस. Rest of the things are same. They both are the neighborhood of C, right? So in set builder form, this neighborhood can be written as all numbers, okay, all the numbers x which belongs to this interval. Okay, so if you are having x is which belongs to C minus delta to C plus delta, then it means x is less than C plus delta and greater than C minus delta, right? X is lesser than C plus delta and greater than C minus delta. Now what I'm going to do, I'm going to subtract this inequality. Okay, each term of this inequality will be subtracted by C now. Okay, so what I'm going to get, C minus delta minus C, x minus C, and C plus delta minus C. So see, this C and this C gets cancelled, and we are left with minus delta. Okay, this will be here, but this C and this C again gets cancelled. So you can see, you can write x minus C is less than delta and x minus C is greater than delta. Okay, so this is your point. And also going bit further, okay, I can write it as modulus mod x minus C is less than delta, right? Okay, so modulus, what does mean by modulus? Okay, if x is less than alpha, this means x is less than alpha and greater than minus alpha, right? So that's why I'm just writing the reverse of this inequality. Okay, so therefore this neighborhood can be written as, okay, where I was, yeah, so neighborhood of this point can be written as all x is all numbers x such that x minus C is less than delta, and this is the delta neighborhood of C. Okay, so in coming lectures, wherever I'm going to write this thing, it means it is neighborhood of what? C. Okay. Okay, and its length is delta, right? So now let us come to the epsilon delta definition of a limit. Okay. So epsilon delta definition. So firstly, don't get confused with the epsilon and delta here. Delta and epsilon are nothing, but these are numbers, right? Okay, epsilon delta definition of, okay, so let me write it, limit of a function. Okay, limit of a function. Okay, so you know what is limit. Okay, so to make you understand this definition, I'm going to take an example. Okay, so let us take fx is equal to x square minus 1 divided by x minus 1. This is a function. Okay, function of x. So we know how to find out the value of value at any point. Like if you want to find out value at x is equal to 0, we can easily find out, right? F of 0 is equal to 0 minus 1 divided by 0 minus 1, which is equal to minus 1 over minus 1. 1 gets cancelled, so we are f of 0 is equal to 1, right? So similarly, if we want to find out value of minus 1, okay, if we want to find out value of f of x at x is equal to minus 1, it is also pretty simple, right? So we will have to write minus 1 square is 1 plus 1 minus 1 divided by minus 1 minus 1, right? So it is 0 by minus 2, which is equal to 0. Okay, pretty simple it is how to find out the value of. Now if we want to find out the value of f of x at minus 2, so it is also pretty simple. 4 minus 1 divided by minus 2 minus 1, right? So it is equal to 3 by minus 3 minus 3, which is equal to minus 1. Simple it is. And now let us, okay, so you can also find out value of f of x at 2, right? So it would be again 4 minus 1 divided by 2 minus 1, which is equal to 3, right? So easily we can find out the value of find value of f of x at 0 minus 1 2 2, okay, 3 4 whatever. Okay, but you see, if I want to find out the value of f of x at x is equal to 1, so we won't be able to find out value of this function at x is equal to 1. Why? Because at this point denominator of this function is becoming 0. If denominator is becoming 0, okay, of something, and there is something and okay, something finite like 2 or 3 whatever in numerator, so it is equal to, we know it is equal to infinity. But when you put x is equal to 0, we get f of 1 is equal to 0 by 0, which is not equal to infinity. It is not equal to 0. Basically it is indeterminate form, okay, which cannot be determined. Okay, okay, so we don't know what it is, right? So we have failed to find out the value of f of x at x is equal to 1. So from this the value of the, or the limit comes into the picture, right? This sort of when we stuck in this sort of problem, okay, limit came into the picture at that moment, right? So if we want to find out the value of f at 1, we will have to okay, we are going to put some value of x which are quite close to 1, right? We are trying to see how does this function behave when we are putting a value quite close to 1, right? हम ये चेक करेंगे 1 पे x का नेचर देखने के लिए किस तरह की वैल्यू आती है. हम थोड़ा x की वैल्यू नियर बाई वैल्यू पुट कर लेंगे, ठीक है. उस पे देखेंगे x की f ऑफ x की कितनी वैल्यू आती है जब x को हम नियर बाई वैल्यू पुट करते हैं. तो उसी हिसाब से फिर वी आर गोइंग टू जज दिस f ऑफ x, राइट. सो सी, if okay, I want to find out value of f at x is equal to 1. So let us see what is f of 1.1. देखिए इस ये कितना आता है. So if you put this value in f of x है ना, फंक्शन में वैल्यू डालोगे फिर कैलकुलेट करोगे, it would be equal to 2.1. ओके, अगेन थोड़ा और छोटा करते हैं, ज़रा छोटा नंबर पे कितना वैल्यू आता है. सो वी आर गोइंग टू प्लेस x इज इक्वल टू 1.01. okay, then if you calculate this would be equal to 2.01. okay, if you again put a smaller number here and it would be equal to 2.001. okay, if you again try to put some smaller than this, okay, you will be getting 2.00001. okay, so in this way as you go beyond, okay, जैसे जैसे आप इस नंबर को और छोटा करते जाओगे आपके पास ये वाला नंबर भी छोटा होता जाएगा. ठीक है, लाइक इफ़ यू पुट x इज इक्वल टू 1.000000000000001, you will be getting a result 2.0000000000001, right? So in this way you can it is coming into your mind, into your brain, that when you are approaching x, जैसे जैसे हम 1 की ओर जा रहे हैं, as we are approaching toward 1, okay, fx is also approaching toward 2, right? जैसे जैसे हम x को 1 की ओर लेके जा रहे हैं, fx कहाँ जा रहा है? fx 2 की ओर जा रहा है, and this thing is called limit of fx is equal to 2. ठीक है, fx 2 की ओर जा रहा है when we are approaching 1. okay, when we are approaching x toward 1, right? So this is what we call limit. So in this way we have found out the value of f of x at x is equal to 1, right? So ये कोई ऐसा नहीं है exact value है, we have just judge the function, we have just seen the nature of the function, how it is behaving when we are approaching toward 1, right? Similar thing, we have approached this from the positive side, right? If this is 1 here, right? So somewhere here is 1.1. okay, then we took a smaller number 1.01, then we took smaller number 1.0001, then we took another smaller number 0.00001. in this way we are coming closer to 1, but we don't know exactly what how function is what is the value of function of what is the value of the function at x is equal to 1. so it is just limit of the function. okay, this is known as right side approach. okay, so we are approaching x1 from the right hand side. Similar thing can be done from the left side, right? So we can try to see what is the value of f of x at 0.9. okay, if you calculate this, if you put the value of this x is equal to 0.9 in equation, you get it is equal to 1.9, right? So again, if you see, if you make this number little bigger than earlier, so that is 0.009, you will be getting value 1.99. okay, so little big now again. okay, so this number would be again getting bigger. okay, so in this way you will be approaching toward 1, and here you will be getting these sort of numbers. So if you draw it on the real line, 0.9 was here, then you made it bigger, so 0.99 here, then you again made it bigger, so 0.999. so in this way you are approaching from the left hand side. okay, so here also as x is, so see 9 from 0.9 you are approaching toward 1, so x is approaching toward 1 from the left hand side. okay, we used to write a minus here, okay, to indicate that we are approaching x from x toward 1 from the negative side, and here sometime we used to write plus because we are approaching x from the positive side. But do not get confused with this right now, because you just understand the concept right now. Okay, what is this approaching thing and how limit work. Okay, so here we are approaching x from the left hand side, okay, toward 1, and what we are getting, we are getting that x is also coming closer to 2, right? So when we are approaching x toward 1, fx is coming closer to 2. So this thing is called that limit of fx is equal to 2 when x comes close to 1, or when x is approached to 1. Okay, so this is what we call limit, right? So in other way we can say that if you take difference of these two, f of x and 2, इन दोनों का अगर यू टेक डिफरेंस एंड यहाँ और x माइनस 1 का भी डिफरेंस ले लो, तो जितना जैसे जैसे इसका डिस्टेंस स्मॉलर होता जाएगा, एज दिस कॉन्ट्रैक्ट्स और दिस डिफरेंस गो गेट्स स्मॉलर, this difference also gets smaller, right? So we can say f of x minus 2 okay, you can say f of x minus 2 becomes smaller, okay, as x minus 1 becomes smaller, right? So this thing is depending on this difference is depending on the other difference, right? So in alternate form we can write it as if this is lesser than delta, okay, some number, positive number, this is positive number, that is this delta is greater than 0, okay, we have taken a neighborhood, okay, in this neighborhood, okay, if this is smaller than some positive number, okay, smaller than some positive number, then this difference must be also smaller than some other positive number, okay, which is depending upon the delta. So okay, or in alternatively we can say f of x minus 2 is less than epsilon when x minus 1 is less than less than some delta, okay, here delta is depending upon epsilon, right? So it is kind of some function of epsilon, right? So basically it means that both the difference are interrelated. When one difference gets contracted, जब एक difference contract हो जाता है, like when one difference gets smaller, the other difference also gets smaller, okay. This is the meaning of this definition. So if I write the definition now, it looks like, okay, when we say a function, definition is this now, okay, a function f of x is said to have limit L, okay, here limit was 2, so generally it is called L, okay. A function f of x is said to have limit L at x is equal to a, okay, a or c, whatever you want to write, okay. A function f of x is said to have limit L at x is equal to c if for every epsilon, okay, every epsilon greater than 0 there exists a delta greater than 0 such that f of x minus L is lesser than epsilon when x minus a is lesser than delta, okay. For this positive number we are getting this epsilon, this delta, this positive number epsilon. For this positive number epsilon we are getting हम ये प्राप्त कर रहे हैं, we are getting this delta such that this difference is lesser than epsilon when this difference is lesser than this delta, okay. हर एप्सिलॉन के लिए डेल्टा एग्जिस्ट करेगा, ठीक है, हर नंबर के लिए कोई ना कोई नंबर एग्जिस्ट करेगा, इसके इट मीन्स दिस, ओके। हर नंबर के लिए कोई ना, हर एप्सिलॉन के लिए कोई ना कोई डेल्टा एग्जिस्ट करेगा सच दैट both the differences are lesser smaller than that number, right? So this is the definition of limit. Now I want to illustrate this definition with the help of some examples. Okay, so let us take two examples to understand this definition, right? So example 1, by the use of epsilon delta definition of limit show that limit x tending to 2 4x minus 3 is equal to 4x minus 5 it is. Okay, 4x minus 5 is equal to 3, right? So we are going to show this by the use of epsilon delta definition of limit. So see here f of x is equal to 4x minus 5 and the limit is equal to 3 and a is equal to 2, right? So difference f of x minus L is equal to 4x minus 5 minus 3, which is equal to 4x minus 8. Now I can take this 4 outside, so we will be having inside x minus 2. Okay, so which is nothing but x minus a, right? So this thing is smaller than epsilon when this thing, okay, whatever is in the mod, okay, not in the mod, whole mod thing. So this difference is smaller than epsilon when this difference is lesser than epsilon by 2, epsilon by 4, because 4 and 4 will be getting cancelled, right? So this difference is smaller than epsilon when this difference is lesser than epsilon. So we can write it as f of x minus L here is less than epsilon when x minus 2 is lesser than epsilon by 4, right? So when it is lesser than epsilon, so this is our delta. So this epsilon, for this epsilon there exists a delta, okay, equal to epsilon by 4, such that this difference gets lesser than epsilon when this is lesser than epsilon by 4. So see what is the meaning of this thing, right? So देखो, अगर epsilon को हम 0.001 पुट कर देते हैं, ठीक है, तो ये इससे छोटा है epsilon पे, हटे, ठीक है? तो ओके, यू जस्ट अंडरस्टैंड दिस, ठीक है? एप्सिलॉन हम बहुत ही छोटा कर देते हैं, 0.01 कर देते हैं, ठीक है? तो ये 4 से डिवाइड होगा, ठीक है, और छोटा हो जाएगा, तो ये इससे इस नंबर से छोटा हो जाएगा, ठीक है? ये और भी छोटा हो जाएगा, जैसे जैसे एप्सिलॉन छोटा हो जाएगा, देयर डिफरेंस विल बी, बोथ द डिफरेंस विल बी आल्सो गेटिंग शॉर्टर, ओके, स्मॉलर, राइट? जैसे जैसे एप्सिलॉन छोटा होता जाएगा, दोनों डिफरेंस भी छोटे होते जाएंगे. सो इन दिस वे एफ एक्स विल बी कमिंग क्लोजर टू एल as x is coming closer to 2, right? So this is the definition, this is what we mean by limit thing, right? So both the differences must contract simultaneously. अगर ऐसे हो रहा है कि दोनों डिफरेंसेस एक साथ कॉन्ट्रैक्ट हो रहे हैं, एक साथ स्मॉल हो रहे हैं, ठीक है, तो वी विल बी कॉलिंग दैट एफ ऑफ एक्स इज हैविंग लिमिट एल एट एक्स इज इक्वल टू ए, राइट? सो देयरफॉर वी विल बी राइटिंग इट एज ओके. सो तो यहाँ पे क्या हो जाएगा, ये वाला डिफरेंस हम एप्सिलॉन कुछ भी ले सकते हैं, पॉजिटिव 0.00001 ले सकते हैं. सो इन दिस वे वी कैन से एफ एक्स इज गोइंग टू 2, राइट? लिमिट ऑफ दिस इज इक्वल टू 2. कब? जब ये देखो, ये एप्सिलॉन, ये वाला एप्सिलॉन बहुत छोटा हो सकता है, सो एक्स इज अप्रोचिंग टू 2, राइट? सो दिस इज द पॉइंट हियर, राइट? ओके, आई एम सॉरी, L was 3 here, right? Okay, so let us take one more example. Okay, example 2. So here by the definition, by the epsilon delta definition, prove that limit x tending to 3 x square minus 9 divided by x minus 9 is equal to 6. Okay, so let us prove this with the help of epsilon delta definition. So again you see f of x here is x square, it is okay, square minus 9 this, and L is equal to 6 and A is equal to 3. Okay, so what is difference between f of x minus L? It is equal to x square minus x minus 3 minus 6. Okay, it can be written cancelling. Upon cancelling we will be having x plus 3 minus 6, okay, which is equal to x minus 3. So see, this thing is lesser than epsilon when this is lesser than epsilon. Okay, so we can write f of x, since these both are equal, these both the things are equal, therefore जैसे जैसे ये छोटा होता जाएगा जैसे वैसे वैसे ही ये भी छोटा होता जाएगा. So we can write it as f of x minus L is lesser than epsilon when x minus 3 is lesser than epsilon. So this epsilon is nothing but delta here. Thus for every epsilon greater than 0 there exists a delta equal to epsilon such that f of x minus L is less than epsilon for all x minus 3 less than delta equal to epsilon. Okay, so therefore we can write, therefore limit of x tending to 3 x square minus 9 divided by x minus 3 is equal to 6. Okay, so this was another example on this. Okay, so thus this is it for today, right? And we will be continuing the lecture series. Okay, we will be continuing this limit of a function topic in the next video too, right? Thank you for watching.